Jangan lupa sampai. Ya, sudah. Pak Dimas Mr. William. Ya, enggak ada. Mr. William belum. Sudah ada, Pak.
Nanti saya pandu ya. Nanti saya pandu.
Oh,
Kadang-kadang nanti saya masuk pandu gitu. Kadang-kadang off nanti.
oh iya. Nih, sesuainya seperti belum.
Assalamualaikum warahmatullahi wabarakatuh. Welcome and good morning, ladies and gentlemen. First of all, let us give praise to Allah Subhanahu wa Ta'ala. Because of His blessing and mercy, we can come and get together without any obstacle and with a healthy condition in the guest lecture in piping engineering. The Honorable Mr. Raden Dimas Endro Wijonarko as the head of Piping Engineering Study Program, the Honorable Mr. Anis Esther, First Vice Director of Shipbuilding Institute of Polytechnic Surabaya, and all of the students of Shipbuilding Institute of Polytechnic Surabaya. Before we start the main session, let us introduce ourselves. My name is Tania Nami Mistika, and I am Anissa Dia Fitriani. We are here as the Master of Ceremony that will lead the guest lecture in Piping Engineering until the end. Okay, the topic that will be presented in the guest lecture in Piping Engineering is about professional piping designer. So, ladies and gentlemen, let us deliver the structure of the event today as follows. First, there will be an opening. Next, singing the Indonesian National Anthem Indonesia Raya. After that, greeting from the head of Piping Engineering Study Program and greeting from the First Vice Director of Shipbuilding Institute of Polytechnic Surabaya. Next, presentation from our special speaker and continue with the question and answer session. And the last session will be closing and documentation. All right, let's move to the next session, singing the National Anthem of Indonesia, Indonesia Raya. Ladies and gentlemen, please stand up and follow. please get back to your seat. After this, there will be a greeting from the head of Piping Engineering Study Program to Mr. Radun Dimas Endro Wijanarko. Time and place are yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, all of the attendants that can attend on this session. First of all, for the First Director of Affairs of Academic, Pak Anis Mustafirin. It's nice to meet you in these sessions. And Mr. William Beasley from the SPD Society of Piping Engineer and Designer from Houston. We are glad to meet you in this moment. I believe that you've been waiting for so long time to see and share your thought to our students. And my beloved students, especially for the 8th semester students who would be this time would be very special to you before you graduate as the piping engineer. There's something that the lectures also Jos and Kusuma as head of department of marine engineering and all the committee, lecture committee, and all of the staff members in piping engineering study program. The committee that make this session would be happen. Instead, we have very short preparations. I appreciate for your efforts. Our aim or our goal that we want to share, and especially for the 8th semester of the students, is you have to know exactly what's the development of the issues on the current workplace, especially in piping engineering. And the session that you have to encourage to answer all the questions about the professional engineers in the world, not just from the Indonesia, but it's considered to be in the world, because this fellow that has attended on the session would be the very senior fellows from the recognized institution. And also you can ask to him, Mr. Beasley, how many that he has ever worked before he joined in our session for this morning. All the students who has the first year, we have all students who coming from the first year. Anak mahasiswa yang dari semester satu ada? We have the first year students. Okay, you can take it. The special message that we will deliver to you for the first year students that you can share about this current issue, and also this session would be make you more motivated. What would it be if you graduate from this study program? The final results was that our institution would emphasize to you is that the session would become as your motivation to study more harder and to maintain your heart and mind to graduate from this study program better and more better than the brother or your sister that will be graduate before. I'm not getting to give a more speech. I'm considering the time is very tight. I appreciate for all of your attention and for your coming from the sessions. Thank you. Have a nice talk with our student, Mr. Beasley. And thank you for Panis. Wassalamualaikum warahmatullahi wabarakatuh. Selamat pagi.
Okay, that was the greeting from Mr. Anis. Thank you so much, Mr. Anis.
Pardon, Mr. Dimas.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Mr. William Belsey, yang saya hormati semua Bapak Ibu dosen, khususnya Pak Prodi, Pak Dimas. First of all, I want to express special gratitude for our campus. It's very because all of us will hear from you global reputation expert for helping internet. This purpose we invite most of our students and we can hear not only in this forum, also virtually we attend from Zoom. Actually, thank you special for Mr. William G. Belsey, and he is also the former chief of SPID, Society of Piping Engineers and Designers. So thank you for your coming here. And also I hope maybe if you have time after the session, you can visit our campus, around of our campus, and also you can visit our laboratory. Maybe for our development, for future development, what should we have to make completed to match the international need? I think it's very important, and I hope your advice, assist, and special advice for development of our institution. And thank you for your assistance. And for all of you, saya terima kasih sekali atas terselenggaranya event ini. Sekali lagi kami mohon adik-adik nanti semua mendengarkan dengan sungguh-sungguh. Ini adalah bukti daripada BPNS, kita berupaya sungguh-sungguh untuk mencapai reputasi global. Dan ini nanti kita harapkan alumni-alumni kita nanti match dengan kebutuhan internasional. Sehingga adik-adik kami harap nanti ke depan itu tidak hanya OJT di Indonesia. Kami pengen kalian OJT di Amerika, di UK, di Kanada, nanti pergi ke seluruh penjuru dunia. Kami harap nanti seperti itu. Dan tidak hanya OJT job training, nanti kami harap nanti berkarir tidak hanya di Indonesia. Kalian bisa karir ke seluruh penjuru dunia. Terus terang saya iri dengan orang India. Saya pergi kemana saja, di situ ada orang India. Terus terang saya iri dengan mereka. Mereka luar biasa berkiprah. Ya, negara-negara Hindustan ya, mulai India, Pakistan, Bangladesh, Sri Lanka, hampir di seluruh penjuru dunia, di seluruh perusahaan ada dari mereka. Maka kita jangan berkalah dengan mereka. Terima kasih dari saya, terima kasih pada seluruh panitia. Selamat mengikuti sesi ini dengan sungguh-sungguh. Assalamualaikum warahmatullahi wabarakatuh.
Okay, so that was the greeting delivered by Mr. Anis. Thank you so much, Mr. Anis, for your greeting. After this, we get to see the short biography of our special speaker.
Trying to introduce myself?
Yeah.
Okay. Well, I've probably spent 30 years developing curriculum and skill definitions for piping designers. I've been the executive director of Society of Piping Engineers and Designers for about 30 years. And I authored their certification program, wrote the tests, wrote the content, and been studying the issues related to piping design, training and certification, employment, and credentialing. So with that and I've just recently stepped down as executive director. I'm getting old, getting hard of hearing. So I've done a lot of work here, but I do have some experience to convey to you today. Probably you're going to ask yourself, why did I come halfway around the world to speak to your group? Why did I do this? I've I'm on the other side of the planet. Why did I come here? Well, I think today when I talk about what piping design is about, you'll find out that you probably are in one of the most unique programs in the world. That the program that they put together for you here is not only outstanding, but completely different from anything else in the world. So I had to come and see for myself what you were doing. So let's get into my slide presentation. I'm going to do the best I can to see it from here. Okay. I want to talk a little bit about piping, SPED, and the digital future that's before you. Next slide. I'll talk about piping design and engineering, make a comparison. And you have a curriculum here that's bridged the gap in a very delicate, very refined way. And that's another reason I wanted to come. We'll talk about what SPED has been doing and what lessons we've learned about piping design, credentialing, certification. I'll talk, okay, I've lost my slideshow. We'll talk about some of the recent developments inside SPED and some of the lessons we've learned. I want to talk about the future, and particularly, I know what students always want to know about, jobs, okay? So I know at the end, if I talk about jobs, I'll always have people staying to the end. So then some takeaways, and then maybe we can have some discussion. So next slide. First of all, there's a wonderful, interesting dichotomy developed over the years in piping, a difference between a piping engineer and a piping designer. A piping engineer is very interested in applied science and physics and math, very applied science oriented. And a piping designer became very interested in applied ilities, database management, model management, a very different point of view. This program has structured a bridge between the two that's quite unique. And I've reviewed the curriculum, at least in outline form, and it's quite an interesting balance. Next slide. The Society of Piping Engineers and Designers was established in 1980 to serve the piping profession, both engineers and designers. We have a worldwide membership, chapters in the US, Canada, Egypt, Spain, all over the world. But we exclusively serve the piping profession. Okay, we do offer professional piping design certification, and we do professional development work and issue recommended practices. Next slide. We're very happy with our certification program for professional piping designers. It's a 4-level program. The basic certification is, can you be properly trained to route pipe from nozzle to nozzle? The next level is, can you quality assure pipe, quality assure work? The senior level is to do equipment layout. And the 4th level is to manage and be a lead, a full scope manager of piping design. Next slide. And we've designed, we've documented these levels of competency. We have checklists and so on. It's a lot of work to define the skills involved in piping design. Next slide. Now, our certification program began in 2002, and we probably certified, probably well into 1,500 pipers, and our content, our training content has been shown to probably 3,000 or 4,000 piping designers worldwide. Next slide. So let's talk a little bit about what we learned from all this. Next slide. At certifying people to a basic level, a level 1, we basically use a test, and we find that testing people on the basics of piping design is the equivalent of about 1 year's experience. If you go through our certification program and pass the test, it's equal to about 1 year's experience. And it means that when people train you on the job, you have a baseline level of skill that helps people start off from a proper training. All of you graduates in this program should be able to pass our level 1 exam, no problem, from what I've seen. I'm pretty sure that you can. Next slide. Next slide. I also did a lot of work defining the minimal skills at a badge level, and I found out that that's not what employers want. They don't want to know how you do on individual skills. They want you to be certified. They want an overall degree, a credential. Credentialing has become a very hot issue in piping design. Next slide. Level 2 is piping quality assurance, and I'll show you some examples of this, give you a flavor for what we've learned from that. But we found there's some general principles to quality assurance of digital models. Now, when you work today, you may have done manual drafting, and your teachers may have done manual piping layout, but almost all piping layout is in digital model form today. And so it presents a new problem. How do you quality assure a piping model? We've looked at that very seriously. We have 6 general principles that we use for quality assuring models, and I'll show you some examples. Next slide. We can check for inherent geometry and topology. We can check for capture of design intent, execution of design intent, presentation of content and structure to another level of detail, traceability to approved data, and adherence to CAD and application conventions. Now, those are fancy words, but I'll show you some examples that I think you'll be comfortable with. Next slide. For example, all pipe is connected. And if it's not connected, that's a problem, okay? In the real world, all pipe is connected. So if you have a model where something's not connected, that's an error. That has nothing to do with the design. It has to do with the inherent nature of pipe, okay? Next slide. Also, piping is a solid, so you can check and see if that solid thing ran into something else that's solid. That has to do with the nature of pipe, nothing about the design itself. It has to do with what pipe is. Next slide. Lines are connected. You don't want to have a design where something's not connected. So you can check and see if something is actually attached. That has to do with the nature of pipe. Pipe doesn't hang in the air. It's connected to something. Next slide. And you see this often in other engineering models. Here's a stress model where some of these disconnects cause a database error in the piping model. And you'll find that a lot of the work you do as a designer will be repurposed by an engineer doing stress analysis. So that data you create in one location will be used somewhere else, and these errors show up in the model. This is showing up in a stress model. Next slide. Also, here's a topology check. The topology in a P&ID, for example, and you use P&IDs in shipbuilding. Okay. A topology in a P&ID has to be preserved in the actual physical model. So we do a check. Everything should be there in the same order and connected the same way. And if it's not, that's a problem. Next slide. Also best practices. It's engineers intend that you don't have pipe routed through access ways, that you don't have pipe valve handles sticking out where it might get hit by a truck. Those are best practices. That's engineering intention that you must carry forward into your design. Next slide. Nozzle tagging. If you tag a nozzle in one document, it ought to be tagged the same way in another document. That correspondence is your responsibility. That's what you have to do. Next slide. Also traceability to approved data. When you have revisions to drawings, you have to show that all these changes you made are traceable to an approved piece of data. That's a traceability problem. Next slide. And here's a rendering problem. Here's a trunnion that was actually in the model, but did not come out as a rendered isometric. Well, why did that happen? It was because it didn't obey the conventions of the CAD system. Okay, so you had to encode it the way the CAD system wanted to see it, or it would not come out properly. Next slide. Here's a model that was disappeared because it had the wrong spec. The model that you see here was extracted based on a piping spec, and this one item was not properly coded with the spec, so it didn't show up. And that's a encoding problem. Next slide. And here's another situation. In this case, it's an orphan vent valve, and it's orphan because it was miscoded with the wrong spec. We've isolated items according to spec. This other item showed up and it shouldn't have been there. Should have been on a different spec. Next slide. So these are the kinds of things that you'll be checking as a piping designer, as a piping engineer. You'll be responsible for encoding this data correctly. You'll be in charge of preserving data integrity. You'll be in charge of accepting data from another source like a scan and bringing it up to the proper level with the proper conventions in a CAD system. That'll be your job. And it's an important job too. Let's talk about the future. Next slide. Now, is there any money in piping? Anybody care about piping? You know, do they care? Well, let me give you an example here. Here's a refinery that makes let's see what it makes. With the cost of money at 4%, here's a refinery that makes $5 million a day. What's that refinery worth? $45 billion if it makes $5 million a day. $45 billion. All you have to do is get it to run right to the first day. From the very first day that refinery runs right, it's worth $45 billion. So is piping important? When you design a plant, if the piping is right and the plant works the first day, the company just got rich by $45 billion. So that's the kind of money that's at stake in these systems. When you build a ship, it's considered the world's largest portable plant. Okay, it's the world's largest portable plant. Some ships now do liquefied petroleum natural gas, liquefied natural gas. They transport petroleum products, they refine them, they process them. These are portable plants. The very first day that ship operates correctly, it's worth a bunch of money. So, but it's got to be right. The piping's not right. It's not going to operate right. It's not going to have any value. Next slide. Now, the other thing to understand about what's happening in the piping profession is that everybody worried about, sending work out to overseas to low-cost design centers. But the answer to low-cost design centers is no-cost design centers. And when you automate, you eliminate labor completely. And I think there'll be a day soon when somebody will have a design for a plant and 30 days later, there'll be a physical plant. And who can execute at that rate of speed? Let's say a ship, somebody wants a ship, they get a big order, the ship has to be ready in so many days. Can they execute? If they can execute, they can get the order. So it's all about who can execute and execute correctly. Next slide. You'll see more imaging. Now, in process plants, they don't want piping designers to go into the physical plant. They don't want you in there. So they do a scan of the plant and you work off the scan data. But how does that data brought up to the same content needed by your CAD system? You have to do that. You have to find out what's in the scan. You have to put nozzles in and put structures in according to what's in the scan. That's your job. That's what you'll be doing. So you'll see more and more scan data, local scans, handheld scans, all kinds of different issues in scanning, photogrammetry, putting physical models back into scans. That's what you'll be doing. It's a totally new area. Next slide. Backup one. We're now working with new areas. You know, we used to work with steel a lot. Now we're working with plastic, high density polyethylene plastic, fiberglass reinforced pipe, all kinds of new materials. And the more temperature that these materials can stand, the more steel pipe they replace. And the problem with steel pipe is it corrodes. It collects barnacles. It corrodes away. It rusts away. But fiberglass and plastic don't rust. So everyone wants to go plastic if they can. The only problem is fire. If you have a fire, plastic pipe all melts. So yeah, I know it's a problem. So I think there's a future in 3D printed parts. Okay, people are making when they make a pump, the pump rotor wears out, gets abraded away, and they can't. And the pump's obsolete. I've seen. I was taken out to a refinery in near Jakarta, and the valves in this plant had Nazi swastikas on them. They were designed by the Germans, okay? And that equipment wears out. How do you get parts for it? Okay, you have to build them, you have to print them, okay? Or print the mold and cast a new part. That's what you'll be doing. It's a retrofit world. Also, corrosion repair. We have ways of repairing pipe. If a plant's going or a ship's going and something breaks, you'll repair it until you can replace it. So we have new technologies in repair and also improved inspection. I'm very glad about this program because you have a lot of fabrication and inspection content in your program. And that's a big issue, not only inspecting fabricated pipe, but also inspecting repairs and determining the need for repairs. Next slide. Another issue is remote collaboration. It's here to stay in the U.S., that some of the work will be done in the U.S., and some will be done in Kuala Lumpur, some will be done in Beijing, and some might be done in Surabaya. And so people will transmit models to you, and you work on the model and add to it and transmit the model back. That's here to stay. So now the question in the US is, how do I manage these kind of processes? We have sun never sets design, you know, a evergreen design. We're always working on it somewhere in the world. How do you manage jobs like that? How do I qualify you? How do I know that you're capable of doing this design, that you have the skills? I don't know that. I have to find a way to qualify you. How do I do that? And how do I manage the work? How do I tell you what I need so that you can do it? That's a big issue in the US right now, how to manage remote collaborative design. Next slide. You're probably wondering if there's going to be a future for you. Has anyone been watching the price of oil lately? Okay, I know I do. Okay, and it goes up and it goes down. But I'll tell you, it's been up and it's going to stay up. And that means there's going to be a big demand for oil in different locations of the world, demand for shipping it around, demand for liquefied natural gas, huge demand. And it's not just because of Russian stupidity. It's just a worldwide demand for fossil fuels. I don't want to comment too politically on green technology. It's a sore spot in the U.S. under great contention, but let me just promise you this, and remember that Bill Beasley promised this to you. Fossil fuels are here to stay, okay? They are here to stay. Okay, next slide. Now, let's talk about the job market. Any of you guys planning to go to work when you get out of school? Nobody's going to work. No, you are going to work? Yeah, who's going to work? Who's not going to work? Nobody, okay, all right. All right, so let me talk about the job market. Students always ask, is there going to be a job for me when I get out of school? Okay, is there going to be a job? And the answer is almost probably yes, and I'll talk a little bit about that. So let me tell you why I think that's true. First of all, there's always opportunities for good people. Always an opportunity for good people. It may not be a great opportunity now, but the good people always get lots of work. Secondly, you've got to understand in this profession you're in piping design is a CapEx job category, capital expenditure, not an operating expenditure, OpEx. It's a CapEx profession. That means when people invest, they're your friend. When people are not investing, they could care less about you. Okay, so it's a CapEx business. And remember that as a professional to save your money during good times. Put your money into land, put it in the bank. I know you all want to get a new car, a new girlfriend, 2 girlfriends. I don't know what your plan is, but be careful about your money because this is a CapEx business. You make a lot of money when you make a lot of money, and when they're not doing capital investment, they don't want to talk to you. Okay, so please understand that. I tell all pipers, save your money. Okay. Secondly, don't forget, rust. Rust is your best friend. Rust. Okay, all these plants you see out here, they're all turning into, iron oxide. They're all rusting away. So rust is your best friend. They always need to replace the plants. They always need to upgrade them. They're always looking for a piper to help them with that. So you'll always have work somewhere. Secondly, next, a lot of work is always at the last mile. Now, that's a term from telecommunications. You know, when you put a transmission wire in and it goes across the whole country, then at the very last minute, at the last mile, that's where all the spending is. The connections, the hookups, the step-down transformers. It's always at the last mile. A lot of piping design is at the last mile. They will always, if they're building ships in Jakarta or building ships in Surabaya, they'll always need a piper to help pipe it up. They'll always need work. Okay, then employers like to hire people with the latest skills. Okay, they've got 10 people that know how to run their CAD systems, but they don't have a lot of people that have had your training, okay, your content, your curriculum. You've been working on the latest CAD systems and you've been working with the latest computer techniques. I taught a class in Kuala Lumpur to graduate mechanical engineers and chemical engineers. I taught piping engineering. And at the last minute, I said, look, be nice in your presentations if you had animation. And I showed them how to do animation in their piping models. Every team had an animation in their final presentation. Now, do you think a piping designer in a company knows how to do animation? But those students, you guys are doing it on your cell phone, okay? You're doing animation every day. So they all produce animation models overnight. So I'm saying companies want to hire people with the latest skills. Now, the last little bit of advice I'll give you there is document your skills. When you go in for an interview, employers will ask you, what have you personally done? Not what teams you were on. I was on this team and I was on this team. They don't care. They want to know what you personally did on that team. Well, I did the pipe stress analysis. I did the quality assurance. I did the class checking. I did the bill of materials. They want to know what you did. So whenever you work on a team, make sure you personally can point to something that you did on that team. Don't be a player. Don't be a team member. They want to know what you've personally done. And they also want to know what you like to do. You know, what would you get out of bed in the morning and rush to work to do? Oh, I love animation. Oh, I love class detection. Oh, I love data transfer. I love model correction. I love scans. I want to reconcile scans. I wanted this. I wanted that. They want to know what you like to do, just because they want to know if you'd be excited to come to work. Next slide. So, how many jobs are there out there? This is a job search on a worldwide oil and gas job search. This shows that there are 1,000 jobs for piping designers worldwide on this oil and gas website. Okay, I did this last night. I thought I would put together this 1,000 jobs. Next slide. This is the jobs in America that are looking for piping designers. Now, I didn't look at every one to see if they're all piping designers just like you, but there's 5,700 jobs that are looking for piping designers. Okay. Now, I did try to do that same search in Indonesia, and they don't use the term piping designers here. See, so I don't know what to search for. But I'm telling you that one company in America that would decide to staff up could hire everybody in this room. One company. Okay, and that's probably let's see, whether it's 100 people in this room.
It's around 200.
Right, they could hire 57 times the number of people in this room. One time, just next week. So, are there jobs out there? Absolutely. Are you ready? All right, okay. So you got to graduate, get good grades, work on projects. Next slide. And that brings me to my next issue for Indonesia, because I know you love your country, and I've been here before, and it's a beautiful country. And so what good is it to Indonesia if everybody in Indonesia is hired by the US? We bring you all to the US 57 times. What good is that to Indonesia? So it's a problem. It's an issue. We don't want to see brain drain. But I understand there's a huge employer here. That employer knows that the world knows about you. They're going to want to make you happy. One part of making you happy is making you happy. All right? And the other part of making you happy is to give you good work and fun work and interesting things and train you, lift your skills up where you are from now, and give you a good job. But they always will make you happy. Okay. Okay, next slide. So my question has always been, in all the places I've gone, to Cairo, Madrid, Seville, Lisbon, Montreal, Toronto, Houston, Calgary, they're always saying, what kind of piper do you want? What kind of a guy do you really want to get? And do you want a piping engineer who does math and science, but doesn't know about fabrication and doesn't know about utilities, constructability, maintainability, contracting? He's just a science guy. You want that kind of a guy? Or do you want a guy who just knows about models on CAD systems, but doesn't know anything about the science behind it? What kind of a piper do you want? And of all the programs I've seen so far, the one program that's amalgamated most of the content has been, if I'm reading it correctly, if I understand it correctly from what I've read, this program has probably the best synthesis of all that. You have a good content of the science, a good content of the math, stress, fluid flow, fabrication, inspection, applications. This program, as far as I can tell, is the best in the world so far in content. And I'm slightly jealous from the US, but you should be proud that this program has been put together for you. It's a very nice program. Next slide.
So
Next.
that's your challenge to empower your skill, to empower your time, your opportunity, and your power for sure to maintain, to make our your skill and to make this moment, Mr. BC said, it is true for you.
So what do I tell you to do to prepare for tomorrow's jobs? You want to walk out of this room, what should you be thinking about? First of all, make sure that you get your skills documented. Good grades, certification, projects that you've worked on, personal projects. When you go into the interview, here's a design I did, here's a bill of materials I did, here's some inspection I did, here's some pipe I welded up. Your stuff, document your skills. Secondly, keep in mind you're working in a digital workspace. From now on, we'll all be working in a digital workspace. And make sure you do a lot of CAD modeling, 3D modeling especially. Then demonstrate these skills on projects. When you do a project work, don't sit in the back of the room and just sign the report. You take part of that project out and you make it your part. I'm going to do this part. I'm going to do the P&IDs. I'm going to do the ISOs. I'm going to do it and make it your demonstration. Finally, don't forget that a program like this is only the beginning. This is only a launching pad. It's a good launching pad, but it's only a launching pad. After this, you have to commit yourself to a lifetime of training, a lifetime of specialty training. Don't let just these courses in this program be your last course. Go take some management courses, go take engineering courses, go take a materials course. You know, keep studying and studying so that your resume grows, your content and skills grow over time. And whenever you apply for a job, I've had this training, I've had this course, I've done this project. They want to know what you've personally done. Next slide. So, first of all, I wanted to explain that piping engineers and piping designers have different bodies of knowledge, BOKs, bodies of knowledge. They're a little distinct, but they're not totally separate. I would say they're synergistic. SPED is trying to serve the piping profession. We've studied this problem and done a lot of work there in identifying these skills. We have a certification program that documents design skills. It's quite successful. We've learned a lot about skills, the skills content in piping design. And I want to just say that the future is bright for everybody in this room, should you choose to prepare. So thank you very much, and I'll take some questions if you'd like. Next slide. Oh, don't forget, if you want to contact us, there's a contact here. Next slide, I'll take some questions. So any questions? Are you excited? Yes. All right, okay. Well, that part's good. So any questions? Yes. Yes. Now, I'm a little hard of hearing, so you'll have to speak up. Okay.
Okay, thank you, Mr. William, for giving me time. So I have two questions, but the first one is, when you say about the future, So you spells artificial intelligence. So is it any connection in piping system with artificial intelligence? Maybe in scanning or in corrosion repairing, something like that. Thank you.
Yes, there's growing content. Artificial intelligence is mainly the application of rules and strategies to automated design. And there's a lot of that. There's photogrammetry, for example, where they put 3D models on a scan. Anything to make your job faster, they'll apply artificial intelligence to. I've seen, for example, a lot of interest in, when I say photogrammetry, it's really 3D scanning of sites for inspection, of developing an initial site. They, more and more, they're not sending people in the plant, they're sending scanners out into the plant and developing a model that you'll work from. I did a lot of work in a project where I never set foot in the plant. But I worked from the scan and I worked from what the piper had put in the scan for me to work from. So yes,
Okay.
quite a lot of applications.
Okay. So next question. I have two questions. So I read on the SPD website. So there is 3 chapters in Canada, in America. So is it possible to create SPD in our campus or in our country?
Up to you. Up to you. If you want one, you can have one.
Okay. So is it any specific requirement to make SPD in chapter?
A student chapter is quite simple, but to have a chapter, it's mainly about submitting a what they call a bylaws, which says how you're going to behave. And we give you a set of bylaws to start with. And then it's a question of holding meetings. But really it's about, the chapter is about you bringing speakers to campus like Bill Beasley, like people from Toyo, coming here to speak to the student body about what's going on, what are the problems, what do I want from pipers, and networking. You know, you have a chapter, you reach out to other professionals, they come and speak, employers come and speak. One thing employers want to do is they want to get to know the people they want to hire first on a personal level. So chapter activities in a campus is a good way to do that.
Okay. So that's it. Thank you, Mr. Wu.
Very good question. Yes. There's a question back there. Okay, over here.
I'm Fikri from piping engineering, and I want to ask, we have talked a lot about piping, but as a piping engineer, I feel since 2018, I start study here, but many subject that we learn, many sub-specification that we learn and we get from this major of study is about downstream or gas transmission pipe. And I want to ask you, sir, if you have, if you will to tell us a little bit about well construction or about well measurement drilling, at what kind of skill as a piping designer that have a direct correlation with that subject. I mean, well testing or well construction and something like that, sir. Well, what a directional correlation and what skill that we need if you in the near future we being a field specialist or something like that, we have a job in there. Thank you.
Well, regardless of what you might hear, this is a profession that's changing all the time. And people are always looking for new ideas. To pretend that if you just study everything we've done 20 years ago, that's going to be enough, that's incorrect. I showed you a picture of Superman, the man of steel. Well, now you have to be the man of HPED plastic pipe and the man of fiberglass reinforced pipe. You can't be the man of steel pipe anymore, okay? So there's so much going on. The way to find out about it is get your knowledge level to a reasonable point. Not perfect, you're not an expert. Get it to a reasonable point and start attending shows, visiting plants, talking to employers. What are you working on? Oh, we just opened a new plant to make plastic pipe. Everybody's asking for it. Or we just, we're doing a plastic repair a pipe. We're doing special kind of inspection. We're doing ultrasonic inspection of hot pipe, which is very difficult to do. We're doing acoustical inspection of tanks. Find out what people are working on and decide if you're interested, okay? And the way to find that out is look in the paper, talk to employers. You should be talking to employers as soon as you know anything. You don't have to know everything. They just want to know that you're interested. Talk to employers, go visit people, get to know what they're working on, who's doing interesting work, read the articles. You don't have to understand everything you read, but you have to get a sense of it. And that's where you find out what you need to know to be successful. And if you walk into, let me give you an example. You walk into an interview here on campus, and you walk in and you say, you know what, I've been reading up on Toyo, and you're doing a lot of work on modular construction, and I noticed that you've been using plastic pipe in your modular construction, and you give the guy a big talk about stuff you've read about his company. And he's going like, oh, you're really up to speed. We like your kind of guy, you know. They want to know that you've been thinking about what the latest thing is. I can't tell you. I mean, I can't. When people ask me, you know, what should I do for a profession? I say, go read the newspaper, see who's hiring. You know, go read the job ads. What are people hiring for? What are they publishing? What are they trying to sell? That's where you find out where the latest thing is. Is that pretty close to? Any other questions? Yes.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fandi Arimulana. I want to ask him about, first of all, this country have a lot of resource, especially in LNG. I want to ask you, Mr. William Presley, first thing is, how is your point of view about our study program, about the correlation about our potential resources? And the second thing is, what makes Indonesian piping engineer different from the American piping engineer?
Okay.
That's from me.
Well, there's been a collision underway, a slow motion collision in the U.S. between two-year trade schools, which train people to be CAD operators, and as if they were draftsmen, and engineering schools who want to create a generalist engineer. Okay, and employers are lazy. I don't know if you've noticed this. Employers are lazy. They don't want to train anybody. They don't want to train. At 8 o'clock Monday morning, they want to charge you to a job. So the problem is the engineering schools want to be general. The two-year associate programs want to be CAD operator oriented. It's almost like typists. They teach you CAD, but they don't teach you anything about why you're doing what you're doing. And there's never been an amalgamation. Well, there has been some attempts, but they've not yet found the right formula. And this college, from what I can tell, has found a good formula. They've got an employer that's sponsored them, you know, to your benefit. And you have an industry that's hiring you. This program is a good balance between science and mathematics and applications. So there's a good chance if I hire you and give you a short introduction to the company, 8 o'clock Monday morning, I can put you on a job doing something. I remember I trained pipers in Kuala Lumpur in piping engineering. I did 8 classes there. And they would go to Technique, Technique Geo at downtown. They would go to Technique and they would start over with the same content I had, but a little bit more detail. And so people would come by and say, I need 2 guys for a project, and they'd pull them out, put them to work. I need 3 guys for a project. They'd pull them out of class and put them to work. And so I guess you're the last guy or something, there's a last guy in the class. He's the guy that hasn't been chosen yet. He's going like, does anybody want me? So that's how it works. They want you to show up trained and with some application experience so they can put you on a job Monday morning. And so this is a good balance. You should take advantage of it. Does that answer your question? And when I compare it to the US, unfortunately in the US, they still want to crank out generalists. There's not enough training, not enough specialization, or there's too much engineering, too much general engineering. Calculus, differential equations, there's too much. You're looking for the right balance. Does that help you get the context?
Yes, that helps me a lot, sir. I just didn't want to repeat my question, but I just want to make a conclusion. So, in every study program, that something that truly dangerous is what is something that make us generalize us it is dangerous, right?
Well, I know there's a heavy shipbuilding interest, but I've looked at the applications. You have HVAC, you have safety piping, you have all sorts of other applications. I've never seen that before in any program. I've never ever seen anybody specialize in the piping area. Never, ever. I don't recall what else I've seen, but HVAC, I never see anybody trying to specialize you to that degree. And I think it's because you're dealing in shipbuilding, and in a ship, everything has to be present. The safety systems, the HVAC, the piping itself, everything has to be present. So they're getting you ready. Remember, the ship is the world's largest portable self-contained plant. So it has to have everything. So that's what makes it kind of unique. Do you follow what I'm saying? I mean, they want to give you a taste of everything here. And that's what makes it different here. Never seen that before. That answer your question?
I guess this was the best place to go. Thank you, sir.
Okay. Any other questions? Well, thank you for having me out today. I appreciate it. Thank you very much for a chance to talk to you. I wish you the very best in your careers.
Okay, thank you very much, Mr. William, for your presentation. We are already in the end of the question and answer session. Thank you so much for the participant. Finally, we get to the last session.
We are genuinely thankful for your presence, Mr. William. Thank you very much for already sharing your knowledge and experience in piping engineering. May it will be useful for all of us who attend today.
And thank you to all of the audience for your attention during the event. Before we end today's activity, let's take a picture together so we will not forget this moment easily. Yeah.
Atau kita foto bersama?
Iya, sekarang foto bersama.
Kalau gitu dipanggil aja semuanya.
Silakan, ini sedang ada sesi foto bersama ya, kita bisa maju sedikit.
Ini berdiri nggak apa-apa? Berdiri nggak apa-apa?
Oke, untuk semua partisipan bisa maju ke depan ya untuk sesi foto bersama. Silakan merapat ke depan.
Di tengah.
Sambil dihitung ya, bisa. Sambil dihitung.
Oke, teman-teman silakan duduk.
Ini teman-teman bisa kembali duduk dulu ya, kita tutup dulu acaranya.
Iya, price aku tadi sudah dulu ada videonya iya. Tadi sudah tanya jawab. Yang dikasih siapa? Oh iya.
Okay, ladies and gentlemen, so the guest lecture in piping engineering finally has done. Once again, thank you so much to Mr. William, Mr. Dimas, all the Shipbuilding Institute of Polytechnic Surabaya student, and all of the committee that has been prepared this event.
I'm Anissa Dia.
And I'm Fania Naomi Mustika.
If in guiding this event we made mistake or offend someone here, please forgive us. Stay safe, stay healthy, have a good day all. Wassalamualaikum warahmatullahi wabarakatuh.